The second law of thermodynamics tells us something about the direction in which macroscopic processes take place. A sugar cube dissolves in water, however we never see a sugar cube emerge from sugared water. The second law thus gives an arrow of time. In isolated systems, the direction is always from ordered to disordered. Focusing on gases, the 19th century physicist Ludwig Boltzmann tried to account for the second law in terms of the statistics of the gazillions of molecules that make up a macroscopic system. These molecules can arrange themselves in many different ways. Assuming all of these arrangements occur with equal probability, you'd expect systems to go from ordered to disordered simply because there are many more disorderly arrangements than orderly ones. In the early 20th century, Paul Ehrenfest, a former student of Boltzmann, came up with a simple model to illustrate this probabilistic account of the second law. The model is known as the Dog-Flea model, and you can see a concrete realization of it here behind me. We have 50 numbered fleas. It would work even better with 100 or 1,000 fleas, spread over 2 dogs, Werner and Erwin. We also have 50 lottery balls, 1 for each flea. The idea is that we draw lottery balls and that the flea whose number comes up has to jump to the other dog. We start with most of the fleas here on Erwin, 45, with 5 here on Werner. Since there are many more ways of divvying up the 50 fleas evenly over the 2 dogs than of putting most of them on 1 dog, we'd expect the system to evolve towards its equilibrium state with 25 fleas on each dog. That's indeed what happens. Ehrenfest's model thus vindicates Boltzmann's idea, but also reveals an important limitation of that idea. The fleas have a tendency to spread evenly over the 2 dogs, no matter whether we run the model forwards or backwards in time. So we do not recover the most striking feature of the second law, the arrow of time. Once we have reached equilibrium, we will run the movie backwards until we get back to where we started from, and show that if we keep the flea jumping going in the negative time direction, the system once again evolves towards its equilibrium state.